Hello, everyone. What I want to share with you today is actually a new project and new data pipeline, which is similar to calculate type of metrics. This time we're talking about internal events namespace metrics. Why we start this story? It's because we didn't support, we are not able to support Redis HHL internal events metrics on namespace level. For that purpose, we will use one table where we have all metrics. It's called Mark Behavior Structure Events Service Ping Metrics, and do a calculation on that using definition from YAML file. How we approach this is actually, if you go in Airflow and look into SAS usage ping and SAS usage ping backfill, we use actually the same code because the idea is get the metrics definition, in this case is from metrics definition YAML file, transform that to SQL or set of SQL statements in JSON file and execute them. Then results will be stored in raw. For internal events namespace metrics, we use actually the same for regular namespace metrics, and it means I'll mark this success because we have more than 1K queries to execute. They can be heavy. We divide it in 30 chunks here. And in case something fails, you can just load the small portion of failing metrics. So actually the mechanism is the same. But what is the problem here? This service ping metrics table is very big. It's 88 billion records and more, and contain the data for a little bit more or almost 2 years back. For that reason, we try to capture only last 7 days of this data or last month of this data. For that reason, we create two DBT models called Mark Behavior Structure Events Service Ping 7 days and 28 days, because in case if you go to metrics definition, you can find everything here. And if you pick up any of the definition, you can easily convert if it's 7 days metrics or all-time metrics, target either this or this table. For all-time metrics, we will go and pick up the big one. With the filters, then performance will not be an issue. So this is the only reason why we decouple all the data sets into three separate tables. Depends on the time frame. We have all 7 days, 28 days, we'll target the proper table. And that is the only reason performance-wise why we separate this. So it's not confusing about the metrics or any logic, it's just make it faster. You can imagine if you have 207 days metrics, if you target one table, most of the things should be cached already, and execution will be fast. So in that time, we're using usage ping warehouse. It's an S size of warehouse, and the all execution here for this DAG is not more than 2-3 hours, which is acceptable for us. And this data will run each Monday, 9 a.m. UTC, just as a follow-up of regular namespace metrics execution, SQL metrics execution, and Redis metrics execution. So with this missing piece of puzzle, we provide comprehensive overview of the metrics for the entire system. So actually now we have 4 of them: SQL metrics, Redis metrics, namespace metrics, and internal events namespace metrics. So this is a 4-piece. All of this data will land into raw database in SAS UGP schema and internal events namespace metrics table. From there, downstream, it will be union with namespace metrics. So it will be very easy to have the full picture about the metrics. And of course, if you go here, now you will see internal events namespace metric backfill. This is actually after refactoring of SAS usage ping backfill, the same building blocks. Before we move on and create this DAG, internal and events namespace metrics backfill, we refactor the code to avoid duplication. So actually common elements for this and these DAGs are the same. If you go here, internal events namespace metrics backfill, you can easily see what you need to define. If you go to admin and variables, you should find one variable which is crucial for the backfill. What you should define? You should define start and end date, what you want to load. It's here. And also set of metrics or just one metrics exposed in a list you want to backfill. In other words, if you define 2 metrics here for defined period of time, you will go into the loop and that will load the data for each week and 7-day metrics, 28-day metrics will be included. All times metrics will be excluded because there is no point to go back in the past and to afford backfill for all time metrics. So this is important to know. Just 7 days, 28 days metrics will be included in backfill. So that's the only parameter you should introduce in order to run backfill. Without that parameter, it will not run. Long story short, now we have 4 types of metrics. We have a backfill supported. We have refactored code in a very good shape, and easily we can extend all of this mechanism with new metrics. How and why? Because only difference between SAS usage ping and internal events namespace metrics is only through where we get the file with queries and where we want to store the data. So actually it's only 2 differences exposed as a setting in the code, which is written in Python. Of course, important to know is internal events namespace metrics, we are automated process fully. Opposite to SAS usage ping or namespace usage ping metrics, where we have a static JSON file with queries, in internal events namespace metrics, we are using fully automated process. You have a YAML file, you have rules, you have algorithm to transform using these rules to SQL and save it as a JSON in a set of SQLs and then exit later on. Everything else is the same. In this way, we created scalable and performant solution. All of these things can be found in Lucidchart if you like graphical representation or in the handbook if you want to read more. Of course, this video will be exposed there. Happy coding.